Hello and welcome. Today we have simultaneous equations. I've done a similar type of simultaneous equations a very long time ago, probably 9 or 10 months ago, when I started the YouTube channel. In which, in that particular example, I went at great depth and explained what is going on. This one's, I'll speed it up a little bit. It's enrichment, but it's not so pleasant, this particular set of equations, compared to what I've done that time. Okay, how do we solve this type of equations? These equations, if you look at on the left hand side how they're written, and we're looking at the polynomials, if you want, the polynomial left hand sides, they're all cubics. Both of them are cubics, not all, but both of them are cubics. That's an x cubed. This is also a cubic term in x and y, because that's to the 1, that's 2, so that's cubic. Cubic, and again 2 and 1 adding together the powers of 1. So the standard way to solve this is to divide the equations. It doesn't really matter which way you divide them. Side by side. So we got something like this. And this is the kind of thing, I'm going away a little bit. I'm trying to teach a few other things and make connection with other things. Suppose we had dy by dx, I don't know, is equal to x squared plus y squared, the whole thing over xy. In first order differential equations, that this is a standard, is known as a homogeneous first order, because this is of all squares. The technical terms you can write as a function of x over y, or function of y over x, same thing really. Pardon me. And the standard substitution for this is y of x is x v of x. So you introduce a new variable, everything cancels in a similar kind of way like this, and then normally these kind of things separate. So it's exactly the same thing. We just need a similar kind of substitution for these equations, and the substitution we need to use is something like y is mx, where m is a new variable, or you can write it as x is equal, it's not the same m, so I don't know, call it lambda this time, lambda y. Okay, so m and lambda, that will be related, of course, one is the reciprocal of the other, but let's do the normal thing, which is to normally call the y. And let's see what happens. So we substitute in there 8x cubed minus x mx all squared over mx all cubed plus 4x squared mx is equal to 1/10. And I'm putting a lot of details still, I don't know why, can't help myself. Minus an m squared x cubed, an m cubed x cubed plus 4m x cubed is equal to 1/10. And the thing to notice, and why this substitution works in fact, is because x cubed, x cubed, x cubed, x cubed. If we've done it the other way around, we'll have y cubed instead. So we'll be cancelling y cubes. So this reduces to 8 minus m squared over m cubed plus 4m is equal to 1/10. And now we have a single equation, a cubic in fact, but in a single variable, m. So let's write it as m cubed plus 4m is equal to 80 minus 10m squared, and let's put it in the usual order. And that doesn't look pleasant, does it? We just hope that this particular cubic has some kind of integer or nice rational solution. It won't be rational because there's coefficient of m cubed is 1. 8 is a fairly large number, so we got 1s, 2s, 4s, 5s really, and then 8s. I hope we don't have to go that far. So let's start putting the box. And let's look at some of the numbers there. The leading thing here is this minus 80. So small numbers are not likely to work. So if we're trying a 1 and a minus 1, if we put 1, 1, 10, 4, minus 80. I'm just very quickly putting ones in there for my m. If I put minus 1, minus 1, 10, minus 4, minus 80, this will not be 0. This cannot make 0. Let's try the 2 and the minus 2. I very much doubt this will work again. So we have an 8, a 40, another 8, minus 80, not a chance to make that equal to 0, and a minus 2, minus 8, still a 40, minus 8, and minus 18, that's even worse. Try the 4, and the minus 4. If it doesn't work with those, we'll cry. 4, 64. 4 squared 16, 160. Oh gosh, the numbers are getting very big. Plus 4 times 4 is 16, minus 80. 2 positive, doesn't work, minus 4. That might work, minus 64. Maybe it's quite big. This will be exactly the same, so that's going to be 160. Minus 16 and minus 80. So what do we get in that? I think that works. 64 minus 80, minus 80 is minus 160. Bingo. Okay. So what have we found? It works with minus 4. So that means m plus 4 is a factor of this cubic, and then we'll be able to finish it off. So you can use your calculator here. Although somebody who's fairly decent with the numbers, you saw it live there. It doesn't take that long. I think actually it's actually much quicker. Pardon me. For somebody who's fairly numerate to do it faster than somebody with a calculator here. So you do a long division with m plus 4, or you can manipulate it. You know how I normally do this kind of thing. So I'm going to pull an m squared, m plus 4. That's your m cubed. Plus 4m squared leaves 6m squared. So 6m squared, which I'm going to write like this. That's my 6m squared. So that balances to that. Plus 24m. Plus 24m. So now we need to lose 20m. So minus 20 m plus 4. And of course, when we're putting the minus 20m there, the 80 now balance automatically. We expect that to happen, of course, because we know this is a factor. So factorize now the m plus 4. M squared plus 6m minus 20 is equal to 0. So for this particular question, either we can actually say m is equal to minus 4, or m is equal to minus 6, using the quadratic formula, plus or minus 6 squared, 36, plus 4, which is 80, the whole thing over 2. M is equal to, what do we have in there? We can factorize, I guess, a 4 out of this. So if we factorize a 4 out of this, we're going to get a minus 6, and that the 4 coming out is going to be a 2, and that we divide by 4, so that's 9 plus 20 over 2. So Rm, hope it's still visible in the video, is minus 3 plus or minus the square root of 29. I think the equations, although you can actually solve, there's nothing wrong with m being these numbers here. But if I was writing a question like that, I don't want people to be sitting there and putting m is equal to this in there to get more horrible rubbish. Although they're valid solutions, I could have put in there some kind of restriction. I don't know what the restriction is. X and Y belong either to integers, if they turn out to be integers, or probably to the rational numbers, because the rational numbers, this will not produce rationals, and therefore with a restriction like that, only this one will be the valid solution. At the moment I don't know, because I copied the question down, and I don't know in the book, probably in my book where this question is coming from, I would have put a restriction. I probably wouldn't have liked this mess. Okay, so what do we have in here? What we have is, let's go back to the beginning. We haven't solved for x and y. What we've done, oops, oh, crying out loud. Let's write it again here. Y is equal to m times x. That's the substitution we used in this equation. Let's clear all the other bits. Okay, I hope you're with me so far and what I've done. Maybe I should have left the other ones, the third bits as well. If they're not too messy, I will actually do this once as well. Okay, so what we're going to do now is we need to pick one of the equation, and of course we found if m is equal to 4. Okay, not 4, m is equal to minus 4. So if m is equal to minus 4, so this equation becomes y is equal to 4x. And then if we take one of the equations, let's go for this one here, or this one, that doesn't really matter, then there's not much difference between them. This will now give us 8x cubed minus x, and now y squared will be 16x squared is equal to 1. So we got 8x cubed minus 16x cubed is equal to 1, minus 8x cubed is equal to 1. X cubed is equal to minus an 8th. We over the reals, so we don't have to worry about cube roots and other bits that are happening when we cube rooting things. So we have a unique solution. X is minus a half, and therefore my y, which is 4 times that, will be, of course, from minus a half times 4. Wait a second. Y is minus 4, and I put y is equal to, gosh, loads of mistakes today. Please will you forgive me. I promise you I've done this before. I know how to do maths. It's just that I'm bad at times. Okay, so here it doesn't actually make a difference, because when I substituted here the y squared, whether I had 4x or minus 4x, is still the same. So the solution is still valid, but I would have got the wrong y, because of course I need to go back into my y, and going back to my y now will give me y is equal to 2. So if I put a restriction, x and y is rational numbers. They cannot be sort of surds, irrational numbers. And then the solution pair is x is equal to minus a half. And as I said earlier on, probably I would have done that. If I use one of the other possibilities, just to show you how messy this will get. Do I remember what was my m? M was, I think, I got minus 3. Plus or minus, I remember it was square root of 29, I think it was. Okay, so if I use this particular one, so my equation is y, let's use the plus version, minus 3 plus the square root of 29, lots of x. And now, where do we put in that? Definitely on the one that has y squared. I don't want to be cubing it by putting it in there and there as well. So look what happens, 8x cubed minus xy squared, and now this is just an utter mess, because we need to square. First of all, that's going to be another x cubed, but I need to square this bracket. It's going to be a 9 minus 6 root 29 plus 29 is equal to 1, and this will now have 8 x cubed minus x cubed 29 38 minus 6 root 29 is equal to 1. And if we factorize the x cubed, that's the best way of seeing this, is 8 minus 38 plus 6 root 29 is equal to 1. So my x cubed is 1 over minus 30 plus 6 root 29, and I hope I haven't made any mistake. I can rationalize that, but getting the cube root of that requires some serious algebra. There's no way I'm going to be continuing with this. I give up. Do not offer me any money. I'm not doing this for anything. It's just a mess, really. I mean, it can be done. It's the expression for something like this is probably something x is equal to something as long as that, or something ridiculous. And then, of course, you have to multiply your x by that to get your y, and you have to do a similar thing. It won't be much different if you put a minus. You can miss some of these steps, but it's not worth it. I mean, the simultaneous equation that you just saw in there, there they are. They're homogeneous. That's the key things that you need to get on board. And I should have put the restriction. I'm going to put it in red now, and that is x and y belong to the rational, so they're not surds, and therefore as soon as you got m is equal to that, you could have crossed it out, and you could have continued just with m is equal to -4, and you would have finished the question. Anyway, I hope you enjoyed this question. I hope you followed it, and you can do questions like this with confidence. They do appear sometimes, this type of questions, in sort of not at university. We don't do things like that at university. This is kind of like on enrichment papers as a step, perhaps, or AEA, or in other countries and have their own similar kind of versions. Okay, so I'm going to be signing out, and I'll see you real soon with more maths videos. Bye for now.